Yesterday, if you remember from yesterday, we were given, here I'll go back actually. Yesterday we were given exponents, right? We had variables in exponential form and we used logarithms to get rid of it. Today we're doing the opposite. Today I'm giving you a log and we're going to use either two options to get rid of it. Okay, the first option's pretty simple. We've actually already done it. The second way is going to be the new part today, okay? So let's just write that down real quick. So like I said, today we're starting with logs and we're going to be using exponents or we're going to be using one-to-one, okay? We kind of have two routes we can go with today, okay? All right. So here's my first problem. Okay, again, today I gave you kind of the list so that you could really just listen. Okay, so here's my starting problem. Notice I have logs on both sides. This is scenario one. Okay, we have logs on both sides. And it's not just any logs. What do you notice about these logs on both sides? They're the same, right? So it's the same logs on both sides, okay? When it's the same log on both sides, we've actually already talked about this, okay? We're going to use the one-to-one property, which if you recall, told me, I'm going to write it off to the side here. The one-to-one property was if log of x equals log of y, then x equals y. Basically, if the log's the same on the both sides, we can just get rid of the logs, okay? So, in our first scenario today, logs are the same on both sides, so I can essentially get rid of them. So now I'm just left with what's inside. I solve for x. I'm done, okay? So again, this one's not new. We've talked about this one before. Now, the new thing we kind of have to cover today is when we're dealing with logs, if you remember our graph for a log, did we have any restrictions we ever had to think about for a log? Did we ever have asymptotes? You don't have to tell me a specific asymptote, but did we have them? Yes, we did. Okay, so when we do these kind of problems, when I give you a log to start, you have to check your solution, okay? When I give you a log to start, you have to check your solution because sometimes what we get will not always work, okay? Now, when I say check your solution, I just mean you're going to come up and you're going to plug a 2 back into the original problem, okay? 3 things might happen. When we plug this in, okay, so for example, I'm going to write this one out just because it's our first one. This is what I would type in the calculator. I'd type this whole thing in. Okay, you're probably going to get a decimal. Then you'll type in the other side. Okay? Now, one of 3 things are going to happen. First option, it works. Okay? This side ends up equaling that side. Okay? In that scenario, our solution works out. The second thing, it isn't equal, okay? I plug it in correct, but this side doesn't equal that side, okay? If that happens, it's not a solution, okay? And the third is you get an error, okay? If you get an error when you type in either side, that just means, like let's say, for example, this one does work, but let's just say, for example, I type in this side and it says error. What that means is that this log isn't possible, okay? So, when you plug in a 2, it's going to work. We're going to get option 1, which tells me you're just going to put a little check mark by it. Just tell me it checks out, it works. Okay, we'll see an example at the end today where there's one that doesn't work. The second, it means it's not equal. That's like a little, equal with a slash through it. Okay? So that's the new part today. Whenever I start with the logs, I give you a log, you have to remember to check your answers now. All right, so that was scenario 1. We have the same logs on both sides. Let's look at number 2 here. In this problem, I give you a log to start with, but it's only on one side. Okay, so this is scenario 2. A log on one side. Okay. So in other words, I can't just cross things off right now. Okay, I don't have the same side. I don't have the same log on different sides. So here's my starting problem. I just copied it down. Here, I'm taking my whole problem, both sides, and I'm making it an exponent on a base 5. Why would I pick 5? Yeah, so it cancels with what? What's going to cancel, Ava? Yeah, the base. So Ava's using this rule right here. She's noticing that I have a big number and then my base of my log is the same. That was one of our rules. When I have the base and then in the exponent is the log with the same number, it goes away. And I'm just left with, let me highlight that actually. I'm just left with what was left. Okay? Where'd the 5 come from? The 5. You just pick it so that it can cancel this one. I could. Yep. It comes from our brains. We have to recognize that the only number that would help me cancel this is a 5. Okay, that's the only number that would make it go away. That's why I pick it. Over here, we don't cancel anything. Okay, this doesn't just become a 2. Okay, we have to leave the 5 over here. So I have 5 squared, so now that's 25. Okay? All right, are we okay on that step? The next one's going to build off of this. So if you have any questions on this one, ask me now. All right, once we simplify our exponent, now we just solve for x like normal. Okay? Now, here's a good scenario. Just look at the board for a second. Don't write this. Let's say this was a little square. How would you finish solving this one? Let's say there was an x on here. How would you finish solving this one if this is what you gave you? What would you have to do? Yeah, you'd have to make it equal 0 and factor. You will see a couple like that. So I just wanted to point that out. Okay? All right, any questions on these two? Notice the difference. Logs, 2 different sides. Log on only one side. Okay, this is our last one, probably the harder one, just because there's more steps, okay? So I have 2 different logs. Are they on different sides, though? No, they're on the same side. But what do you notice about the logs? They're the same base, right? So they're both base 10. Okay, I'm just going to zoom in on just this side. I'm going to ignore the equals 2 for a second. I'm just looking over here. How could I condense this and make it 1 log? Look below. What are we doing? Yeah, we're multiplying, right? So we're using the rule from our last test here to condense. Okay, so if I give you 2 logs on the same side, make it 1 log. It's going to be either plus or minus. So you're going to either have to multiply or divide. Okay? So this first step here, all we're doing is we're condensing. Okay? Which is what you took your test on Monday. Okay? My 2 stays the same. Nothing's changed so far on that side. It just comes along for the ride. Now at this point, over here, this is just this problem, a log on one side. Okay, so the only thing new about this third problem is that we had to condense first. But now this looks like problem 2. Okay, I have a log on one side. I'm going to take this whole side and make it an exponent. I have to pick the right number, though, or else it won't cancel out. Remember, this is a common log, so there's a hidden base 10. So I have 10 raised to the log equals, I have to put a 10 on the other side, raised to the 2. Okay? When I do that, my 10 and log cancel over here. So I'm left with just my exponent. And then I simplify. 10 to the 2 becomes a 100. Oh, here's an example of what I just brought up, right? So now this time we have to factor. Okay, and you would simplify all the way down until you have an x equals 5 or an x equals negative 4. Now, this is the one I want to point out for checking our solution. Okay, so right now, I want you to check these two numbers. Go plug them back in up top. What's nice is your log button here is in your calculator, so there's nothing fancy. So go type this whole thing in, and you should hope to get a 2.
We have to check every one. Like when we do it.
Yep.
Do we have to like show the work of checking, or can we just put it in the calculator?
You can just put it in the calculator. All right, so we're testing our two different answers now. Again, you don't have to write this out on your test. You just have to show me a checker of x. All right, so 5. Does 5 work out? Yes, 5 works. So 5 is a solution. What happens with negative 4? Error. So here we see an arrow, so this one would not work. Okay? Doesn't mean you did it wrong. It just means we'd have a negative log. We can't have that. All right. Any questions on this last one? This step right here. So it all comes down to, here, I'm going to erase for a little bit so you can see this. We look at this line. I want to get rid of this log. I can only get rid of the log if I put it in the exponent or I do the inverse, right? When my big number matches my base. So what is my base of this log? 10. That's how I pick this number. And that's what allows me to cross it off. Okay? All right. Just like yesterday, I'm going to pick one with an ln here to do together. And then you guys are going to work on these the rest of class. Let's do, which one? 48. All right, find some blank spaces. We're going to do 48. You can flip your paper over, I think. If you want to grab scratch paper, you can do it on that because you have to turn it in anyway. All right, so we're working on number 48. Okay. So here you have ln. Now, if you have anything that doesn't have a log in it, just move it over to the other side. Okay, so for example, at my 1 right here, it doesn't have a log attached to it. It doesn't have an exponent, so let's just put it with my other constant. Okay, so I'm going to subtract 1 from both sides. Bring the negative 2 ln x down. I get a negative 5. Now, do not combine that and make that a negative 1 ln x. No, don't do that. Okay? Sometimes kids like to do that because they see it comes first. All right, now we're going to divide. I want you to divide both sides by negative 2. Okay? Trying to get my ln x by itself. Okay, you can make it a decimal or you can leave it a fraction, up to you. Okay, if you have made it a decimal, it'll just be 2.5, so I'll do that because it's a nice one.
So number 48.
All right, and now my goal is to get rid of that natural log. Well, what's the base of this log, technically? E, good. So I'm going to choose E to be my base as I raise the whole thing to E. Make sure you do it to both sides. Yes. Yeah. Okay. Okay. Because it's base E. I picked the E because it's an ln. Okay. All right, so now these cross off. I'm left with just x, which was my goal, equals, and then you can just type that into your calculator. E raised to the 2.5. We get a decimal, 12.182. Remember, we're always going to the third decimal place now. Okay?
No, we already did this one with you, right?
Yep, you don't have to do this one. Now, again, what I said yesterday, the hardest part about these problems is going to be figuring out what it is you're supposed to do. Okay? Get your logs by themselves. See if you have to condense any. Okay? When you're done, you're going to turn it in just like yesterday. Okay? We just did 48 together, so you can cross that one off. Okay? Yeah, I can do that. Can you see that okay? I can't really zoom in anymore, but... Yes, just like yesterday, bud. I gave it back to you yesterday.
No, it's
Oh, yes. Sorry, I thought you meant like I had it.
This is your work experience.